So we are doing questions on gravitation. This is another class on gravitation. I'm doing November 15, 41-1. A satellite of mass ms is in a circular orbit of radius isolated uniform mass. This is their favorite language. And I always tell in my theory classes that A2 chemistry, A2 physics is very formal. And these are the two assumptions. One is the point mass and second is the isolated mass. Show that kinetic energy of the satellite is given by this expression and G is the gravitational constant. Examiner is giving me 3 marks for this kinetic energy work. Radius this time is x. So either I start from Kepler's third law and I work from that side, or I can jump directly to the velocity formula. And derivation is obviously the speciality of A2 physics. Kepler law is the most important derivation. So as the marks are higher, it's only not a 1 mark question. So I will call Kepler's third law. Kepler law never comes by name. Kepler's law never comes by name. It is always in its derivation. So what is Kepler law saying? Kepler law says that gravitational force is equal to gravitational force provides centripetal force. So I call Newton's third law. I'm sorry, Newton's law of gravitation. I call Newton's law of gravitation and I will be using letter X. Satellite of mass ms, and what is the mass symbol he has used for? No, he has not used any symbol for Earth. Has he used? He has used capital M. Okay, fine. This is the first step. Ideally, you people should be working with me. It's November 15, 41-1. Ideally, you should have you should be doing in your past paper book, or not ideal, but obviously the last choice. If you have a digital book, you can write on by a device, but do not. It's not beneficial to write on loose paper because eventually they will be lost and practice is not there. We technically need practice on our printed pages. So I equate it and I can cancel 1x also. This is the situation. I got the value for V square. Now we know that kinetic energy by definition is half mv square. Here the kinetic energy will be half ms, and in place of V I can write gm upon x. So then you rearrange it. If you rearrange it, you will get g msm upon 2x. This is the derivation. So please look at the derivation and you should copy it as it is. state an expression in terms of G, M, Ms, and X for the potential energy. Now, how I can write down potential energy directly? Does anyone remember any relation between kinetic and potential in gravitational field? The symbol is U. This is coming from the memory. Kinetic is equal to half. Usman, can you check it back? Kinetic is equal to half. Is it a memory function? You're right. But you obviously is you're using memory. That's very good. So actually kinetic energy is the half of potential. So if you remove the denominator 2, you will get in potential. Second feature is the negative sign. Second feature is the negative sign. How we find the total energy, in a system of gravitation. Total energy is always potential plus kinetic. I have the potential minus G ms m upon x plus G ms m upon 2x. So as all derivation style, I can take common G m m upon x. Everything is common. Minus 1 plus half. So please tell me in LCM form, what is minus 1 plus half? What is minus 1 plus half? It's a simple question I'm asking. What is minus 1 plus half? Minus 1 plus half LCM. But do not go in decimal, keep it half. So share this step. Small resistive forces acting on the satellite cause the radius of its circular orbit to change. A very interesting concept. Many people, even teachers, say that actually in the space there is no resistance, but actually small resistive forces are present. We are not in a position to discuss them. Why? Because this is not in our course. But in space there are some minor resistive forces. Satellite cause the radius of its circular orbit to change. Use your answer in A to state for the satellite whether each of the following quantities increase, decrease, or remain constant. Now you have to read the previous, you have to look at the previous parts, all of them. You have to see the plus minus. And he says that satellite orbit is changing. And he says answers. Total energy from our earlier physics knowledge, total energy should change here, because normally we say total energy does not change, but there are resistive forces. There are resistive forces. So if there are resistive forces, they will consume some energy to overcome the resistive forces. So the total energy means kinetic and potential will decrease. If total energy decrease, when you lose energy, you cannot go away. The radius will shorten, because with the less energy, you will move in a smaller orbit. Potential energy. Now, these 2 points are very, very challenging. The satellite is coming inward. Satellite is losing the radius. Satellite is moving inward. Now, my question is there, what will happen to potential energy when it is coming closer to the source? From our O-level physics, when you are coming closer to the source, what will happen to potential energy? When you are coming closer to the source, potential energy will definitely decrease. What will happen to kinetic energy? Radius is decreasing. When you look at the formula, kinetic energy formula has no negative sign. X is the denominator and X is decreasing. X is the denominator and X is decreasing. So when you look at the formula and you see it's inversely proportional, look at the formula. I type the formula here, even though it's not required, but I want to show the relation, because this is a very difficult question in the paper. You can see that EX is inversely proportional to X. So when radius is decreasing, the kinetic energy would be increasing. This is our next question. Their favorite part is there. Please read the question and try to answer the first 2 parts. You can easily answer the first 2 parts. I'm just coming. Please read the question and answer the first two parts